Okay, let's look at one example where an experiment actually failed. Google had tried something in Toronto called Sidewalk Labs. The idea was to go towards sustainable building technologies, and you can see these are like piled up wood or so. So they imagined building high rises with wood, which is happening in China to some extent. It's possible to build high rises with wood instead of with cement and concrete, and which is got very high footprint, and many of them are deconstructed after a few decades and rebuilt, producing all that trash and of course emissions and so on and so forth. Cement and steel remain very high emission industries as well. What happened? The lab started in 2017 and closed down in 2020. So there were some crucial lessons to learn from the K-side, which is the place used for this experiment in Toronto. Building technology-driven sustainable communities building technology-driven sustainable communities requires balancing data for efficiency and environmental benefits with residents' privacy and trust. Future projects would do well to prioritize transparency, involve community input, and ensure a clear understanding among all constituents as to how data will be used. This balance is delicate but vital for developing smart cities that are not only technologically advanced but also socially responsible and trusted by their inhabitants. So co-production of solutions, especially when interventions are involved. You may want a smart city, but if that's going to affect people and demands that they change certain things in their lives, then they have to be involved from the beginning, and you cannot surprise them at the end. So what are the opportunities then in enabling AI for nature and climate? We'll look at some foundational advances, untapped or underfunded areas in AI for nature and climate, and in how to build an environment that will enable AI solutions that we want. Again, I won't read all the details, but AI is already making substantial advances in many areas of climate and nature, but important gaps to advance climate and nature solutions remain. Opportunities for investment and development in this space fall within three main categories: foundational advances in AI, untapped and underfunded areas of opportunity, and the enabling environment for AI solutions in climate and nature. So foundational advances then, following focus areas were identified in the workshop as integral to enabling the foundational advances in AI necessary to realize transformative change in climate and nature solutions. So critical data gathering and infrastructure. Data is going to be so critical. Multimodal capability that we already talked about several times. So vision language models, for example, represent the current state of the art in multimodal AI. For climate and nature solutions, advances beyond current AI foundation models that can incorporate multimodal analysis such as acoustic, satellite imagery, multispectral, point cloud data, and so on are needed to better combine and analyze the data coming from different and heterogeneous sources in order to provide a holistic understanding of ecosystems, support more accurate environmental monitoring, and produce more robust and reliable predictions. This is what is going to convince everybody that AI is really going to benefit everybody. Better predictions, economic, computationally, employment-wise, maybe it will create more jobs, but it will be more reliable. Unified data platforms. Of course, the absence of a centralized and unified data platform is a major barrier to progress in the use of AI to develop climate and nature solutions. Okay, so that will need to be dealt with because typically we get data from a wide range of sources as multiple data streams, and they have physical variables, social variables, socioeconomic variables, chemistry, ecosystem, and so on. So we need to deal with Earth system, which is really the feedbacks between physics, biology, chemistry, and nature, right? Open data, well organized and open data following fair, findable, accessible, interoperable, and reusable data principles. is needed to upscale the use and reuse of data. For example, the value of free, open, well-structured data is clearly illustrated by the experience of the US Landsat satellite program, which saw a more than 100 times increase in the use of its data shortly after it became free and open in 2008. That same data had existed for 3 decades but was only put to limited use by the specialized community that had access to it. This has worked out many times that such rich data, once you give it to people, all kinds of details, discoveries, insights, understandings come out, and suddenly the data feels like it was worth the money spent on satellites to collect this data. Satellites cost a lot of money, by the way. Open codes can foster valuable partnerships and collaborations between academic institutions and public and private entities, and are therefore critical to accelerating progress for AI solutions. So you know that OpenAI and ChatGPT, all these are trying Meta, all these are trying models of open source codes that people can plug into and improve and expand and so on and so forth. So that is open codes, and this is open source models. Open source LLMs like Meta's Llama, I just mentioned Meta, or the recent Mistral model by Mistral are leading to rapid innovations, iterations, and collaborations between industries and the public sector, academia in particular. So everybody is not as easily convinced. Okay, so always there are people who want to keep the IP, keep source codes proprietary, and then try to sell licensed products or licenses to use the software and so on. Domain-specific data for training. Foundation models often lack domain-specific knowledge required for certain applications, and adapting these models to new domains in the climate and nature context may require additional model training. Example, in some parts of the global south, a dearth of essential ground truth data can limit the development of new energy and power systems. This data, which would be readily available in other regions, is necessary to leverage AI for such potential applications as geolocated rural infrastructure, such as household access, farm mechanization, diesel use at businesses, and so on. Private preserving data sharing. So if people are contributing or people are being monitored, observed without their knowledge even, then mechanisms to upload and share data with the ability to control acceptable privacy protection levels are needed. Such data needs to be used for training AI models with maximum utilities for public good. Such data needs to be used for training AI models with maximum utilities for public good. So oftentimes it's an opt-out rather than an opt-in. So you are by default be monitored, your location, your screen use, your search history, your call history, and so on, and you have to go in and find a place to opt out of this tracking, and that data, how is it being used? Are you benefiting from it, or are you being harmed by it? Okay, so all these are critical issues about privacy preserving data sharing. Rainfall is an example where there is a patchwork of data around the globe, weather station data, radar data, and privately held microwave station data from cellular communication towers. So that's a co-benefit of using that data to derive precipitation. Being able to fuse those data sets while sharing them securely and publicly would dramatically accelerate applications of AI to climate and nature solutions. What are the untapped or underfunded areas? Again, there are AI for energy management. AI can be leveraged and scaled up across many aspects of modern energy management, including grid energy storage optimization, prediction enhancement, and the optimization and integration of renewable and mixed energy sources, and so on. That needs more funding. You have carbon capture and storage, which is going to be very necessary as a part of the solution portfolio to stay on a reasonable under a reasonable global warming by 2100 with a certain high probability. So there you need to put more energy on AI for carbon capture and storage, and of course AI for soil health and carbon sequestration. Soil is a very good place to hide away some carbon and make soil properties better, increase crop yields, reduce drought or increase drought resilience, and so on and so forth. So major impediment to arriving at correct estimates of carbon storage and requires additional investment in terms of AI for soil health and carbon sequestration. Okay, what is the major impediment? I jumped a little too ahead there. AI that can now be done at the individual tree level, but soil carbon quantification remains an open problem due to lack of observations and scientific investment in this field. This is a major impediment to arriving at correct estimates of carbon storage and requires additional investment. As I said, if you start paying farmers for sequestering additional carbon into the soil by doing agroforestry or low tillage farming, organic farming, whatever, then you have to quantify how much additional carbon was sequestered by them. So these methods can be done with these quantifications can be done with AI, but we need to invest more there. Climate prediction analysis and modeling. Of course, this has still got a long way to go. So we need efficient resource allocation to combat climate change and minimize the impact of disasters on vulnerable communities, and AI can help a lot, as we already saw. Biodiversity mapping and species protection. This needs more AI and more investment. So leveraging low technology citizen science solutions can also be used to expand the reach of conservation interventions, where you will maybe crowdsource biodiversity data, conservation efforts, and use AI to synthesize the data, train the models, and provide action items for preservation and so on. AI for small farmers, this is very important. There is transformative small efforts needed for small farmers who actually lack the capacity to invest in expensive large-scale solutions, but can the data collected by others for all other purposes as well as specifically for farming, can that be used to help subsistence small farmers who are not rich enough to buy instruments or even buy AI products, for example. So there is equitability and so on coming into question. Again, equity and justice and so on. Environmental justice and inclusive climate action. Climate impact is tightly connected to social inequity and racial redlining, as undeserved communities are typically most vulnerable to and simultaneously least responsible for climate change. It can be used to address environmental justice and ensure inclusive climate action and adaptation policies, yet this is still an emerging field. For instance, AI can be used to identify the impact of extreme events such as heat waves or inundation on vulnerable communities and determine how best to adapt to these negative impacts at reduced cost. Okay, so there is behavioral change needed. AI can develop personalized recommendations and targeted communications in many languages that can then potentially help individuals to basically understand how many unintentional things that they are doing which are bad for the environment or overall emissions and so. So use of AI to translate recommendations and communications in different languages and even dialects could further extend the scale and reach of such communications. Okay, so this also again includes collecting a lot of personalized data, so preserving the privacy there is critical as well. It's a good thing that it can take all your data and say you need to reduce this and you can increase this and so on and so forth, but it's your personal data. What happens with it, right? So the environment enabling AI solutions, data sets and benchmarks are needed. Interdisciplinary collaborations are very, very, very critical. Earth system science in general is all about interdisciplinary research, collaborations, actions, solutions, etc. Some people keep on complaining, crying that one person cannot do so many things, but you should let your research take you where it goes and always maintain quality. Idea is not to do few things, idea is to do everything at high rigorous quality with scrutiny that can ensure that everything you do is really world class. Okay, so educational training and workforce development is of course needed. Public education and demystification of the science of AI will allow individuals to understand the power of AI to improve outcomes, which would likely lead to more acceptance of the use of AI in a wide variety of contexts. Right now, AI is creeping into everything, right? Your TV, your car, or your watch, your laptop, everything has got AI now. Even a simple Google search now does AI at the top, and this is all energy. And now already people are saying you can minimize energy use by turning off this Google AI input at the top of your web search. Okay, so there's always this dance that's going on of very useful things come at energy cost, emissions, but you want to reduce all that in this context, right? Optimal policy and strategy formulation, of course, always good for everything, but especially for AI as it becomes all dominant and so on. 8 spotlight initiatives from AI for Climate and Nature workshop report. So here are the headlines I will read. Characterizing emissions, a global, accurate and authoritative account of greenhouse gas flux, separated out by origin and owner. Optimization of clean energy systems, AI accelerated building decarbonization. These are initiatives. Biodiversity data infrastructure, unleashing AI-enabled decisions for a thriving planet through the data mesh. Ecosystems mapping plus geospatial models, transforming access to geospatial information that accelerates pathways from data to insight to impact and action. Sensors, the Trillion Sensor Challenge. This initiative aims to integrate vast, smart and affordable sensors into both land and aquatic ecosystems to grasp each ecosystem's vitality, focusing on individual species behaviors. Okay, restoration, trees for life, incorporating local and tribal knowledge, advancing climate justice through decolonization of data. There are all these implicit dominance by the Western world or the global North, and this has to kind of end. So that comes also with reducing the loss of traditional local and tribal knowledge. Especially when you do adaptation, external experts may come and do things without using the indigenous knowledge, which can cause maladaptations, for example. Okay. Decision making, Climate Policy Tracker 2.0. The primary aim of this initiative is to connect decision making with practical, on the ground climate and nature focused actions. Climate Policy Tracker 2.0 serves as a user friendly interface connecting a live global map of climate and nature regulations with their real world impacts, supported by a thorough set of evidence based decision making tools. Okay, so let's read off the conclusion. I'm not going to go into appendices, of course. Contributions, methods, and systems change lab, and stakeholders and initiatives that were used in the report. So this is the last slide, I think. Yeah. AI holds immense potential for driving positive change in the world. Still, it's a tool, not a panacea. It's a tool, not a panacea. There are people who design better tools. There are people like me who will use the tools, and maybe we can provide feedback to the people who build the tools, which is what needs to happen, because computer scientists, mathematicians, and so on can be so focused on the techniques without knowing all the applications, and when I use it for an application, I might find things that it is lacking or some things that can get better and so on. As with any transformative technology, safeguards are needed to ensure that solutions leveraging that technology are enabling ethical, equitable and actionable decision making, while still providing assurances that insights and recommendations will lead to positive impacts with few unintended consequences. This is very critical. More broadly, AI solutions for climate and nature need to be advocated alongside large-scale innovation and policy overhauls aimed at changing the underlying socio-economic and political systems that enable and perpetuate the climate and nature crises. Okay, so basically it's like saying don't just do CCUS, carbon capture and sequestration, and keep on emitting CO2 because it still has a hysteresis effect, so acidification may go on, health impacts and various other things. So just because you are taking out the CO2 you are putting in doesn't mean you keep the climate steady necessarily, right? AI technologies and approaches alone cannot solve these challenges. New collaborations, more and different kinds of data, and openness are just a few of the things required to solve these inherently complex and multidisciplinary problems. AI has already transformed many aspects of science and society, and it offers us a way to dramatically accelerate the pace of solutions to our most intractable problems. There is much we can liberate, but still much to be done. Okay, so with that caveat or note or conclusion, this report is finished. There are two more reports that I'm going to summarize coming out of Bezos' Earth Initiative, or whatever it's called. What is it called? Let's go back and see so that I don't say something like that. It is Bezos' Earth Fund. You know, this guy is very rich, top 3 or so always, so we want to use his good heart and do some good things with his money, which is what he's trying to do. Even if he benefits from it, if something good comes out, good enough for us, right? Okay, see you in the next report on this related topic then.